Hello. Wait. Okay, let's get started. How's the midterm exam? Yeah, it should be very hard, right? As I told you before, we don't have much time to do all the questions. So don't worry too much for the midterm exam. Like, the midterm exam is the hardest exam, like for this course. And comparing to the assignment and the final exam, the midterm exam is the hardest one. So don't worry too much. And if you like, even you didn't do it pretty well, you can still get HD because I think they may be scale up, but it's not guaranteed. But in my memory, it is not about the like pure marking. It is based on the ranking of the students. So don't worry too much. And let's focus on the Lab4 right now. Lab4 is pretty easy and we don't have much programming stuff. So let's have a look of the exercise 1. In here, we are going to use the Wildshark to analyze the TCP packet, and it will be pretty fun. And let me open the Wildshark first. So all you need to do is just click this link and download the file. Then you come to here. And after you open the trace file, it will be, looks like this. So you can see a lot of protocols here because we only care about the TCP. So we just type TCP here. Sorry, TCP. Then you can have a check. We have lots of TCP packets in this trace file. Then we can start to do the question 1. This is the question. Before you do that, please follow these steps. Because we need to set the preference at first. So you open the preference in here and find the TCP protocol. TCP. It's in here. So have a double check of the options here. So we don't want you to tick these relative sequence number options here. So you need make sure you didn't select this one. Otherwise, you will have totally different sequence number than we have. For example, if I select this one, you can see this number become number one. And this is not true. So go to the preferences, and when the protocols come to the TCP and untick this one, then select OK. Then you will have the real sequence number in the packet. So this is the first step. Otherwise, you will have wrong answer in the question 3 and 4. So let's do the question 1 right now. What is the IP address? And what is the port numbers? This is pretty easy. So firstly, you need to know like how could they communicate with each other? For example, here. In here, we can see there are 2 different IP addresses. And which one is your IP address? You know which one is your IP address? Maybe this. So in the left hand side, 192.1 is you. This one is yours, and the server is so they will communicate with each other, just like what have you learned in the class. Firstly, you need to send a handshake, so it's SYN and SYNAC, and then we can send the data like this. Yeah, and the data. So that's how they communicate with each other. So as you can see here, the first transmission is the SYN and SYNAC. This one is SYN and SYNAC. Then we can have a check if they do have SYNAC and the data in the trace file. So we come to the first one, the SYN packet. You can play around with the Wildshark, then you can see there are a lot of headers in this part, including the source address. You can also have a look of the IP address in here, in this window. You can see the IP address, and if you want to have a check of the port number, then you can find it in the TCP protocols section, the 80 and 1161. So usually the 80 port number is for HTTP. So we are trying to visit a website. And if you go through the packets, then you can see some headers in here. As you can see here, the post, P-O-S-T, is the HTTP method, right? And this is the payload. So you can see we have the SYN and SYNAC at first, then we send a request to the server. Then we may have some response in other packets. You can have a check of it later. But for the question 1, to answer the IP address and the port number, then it should be not a problem for you. Just check the IP address and the port number. You already know how to find it. And the second question, what is the sequence number of the TCP segment? The sequence number, you can also find it in here. So just come back to here, find the first packet of the request. Then you can see here, you can find the sequence number. So you can right click it and apply as a column. So you can find it in this column. It will make you easier to do the question. You can show the sequence number in this window. So just right click it and apply as a column. Okay, that's the sequence number. And the sequence number containing the HTTP post command, right? So it is this one, the fourth one. Make sure you choose the correct one. And we come to the question 3. For the question 3, we are asking lots of stuff. Basically, the calculation. We have a question here. How do we know it is the fourth one for the question 2, right? So the question is, what is the sequence number of the TCP segment containing the HTTP post command? This is the important point. So this is asking about the post command. So we need to figure out which one is the post command in the TCP segment. If this one in the HTTP segment, it would be very easy to identify. But in the TCP segment, we can only identify in this area. So you can just click the packets one by one, just check it in the payload area. So that's the message sent by the client. And this is the response. We cannot understand, but we can go through. And then in here, you can see there are some string that you can recognize this, right? This one is the header of the, oh no, this one is the request of the client. You can see the post and the destination and the host is the header and some other header in the following. Does this make sense? And this is also the header. So you can see there are a couple of TCP segments combining to a HTTP. Yep. So that's how we figure out why this is the post request. Okay, so we come to the question 3. So for the question 3, I put the steps at the end of the GitHub links. Lab4, question 3, you need to draw a table like this. Let me copy this one and let's figure out how to draw this table. Give me a sec. Let me open my Excel. Okay, can you see that? This is the Excel. Hmm. Okay, so this is the table that we want you to draw. And let's see how can we get the first segment. We are looking for the first 6 segments, right? Yeah. Yes, so we need the first 6 segments in the TCP connection. And including the HTTP post in here. Then it should be, I already provided you the first one. And let's see how can we get the first one. In here, you can see the first one is this one, the post crest. So what is the length and the sequence number? Sorry, I made a mistake in here. Should be like this. The sequence number, we already know how to find it. And the length, you can find it in the header. Just find it somewhere inside, in here. You can see it's 565. And the send time, you can also have a check of the time in this window. It's 026477. Yep, and 477. And the receive time. So you need to figure out where is the acknowledgement of this packet by clicking the acknowledgement. So in here, you also need to figure out what is the acknowledgement number here. You can find it in this window, just next to the sequence number. So in here, I apply as a new column in here. So make it easier to find the acknowledgement. So where is the acknowledgement number for the number 4 packet? You can say it's 0.05394. So how can we figure out where is the acknowledgement number here? Do you have any idea? If I give you the receive time, it seems like this one, right? How can you figure this out? Like if they are the acknowledgement for this one. This one is very straightforward. You can see the stuff is the key point is to use the acknowledgement number here. You can see they are the same. Right? The first acknowledgement number is the same one as the second sequence number. And you can also find some relationship between these two. And what is the sequence number for the first one? Is 2321290013, and plus the length 565. So you can find this one. So usually we use the sequence number to find it instead of the acknowledgement number, just in case they have retransmission. Then you will know if we want to find the corresponding acknowledgement number, then we need to do the calculation based on the sequence number here. In here, you just plus, do the calculation. The 565 is the length of the packet. You can consider this one as the data size. So the sequence number plus the data size will equal to the acknowledgement number in the acknowledgement packet. That's how we figure out this is the sequence, this is the acknowledgement packet, and that's the time we want here. We want this time and put it in our table. And then we can do the second one, and I will show you how to do the second one. For example, we want to do this one right now. Let me make clear all the stuff. If we want to do this row, the second packet, how can we figure out where is the acknowledgement packet of this one? Then we need to figure out what is the length of the packet at first. So we come to the should be in here. Yeah. So we come to here and find what is the length of the segment 1460, right? So it's 1460. And the packet, what is the sequence number? Is this one. We just copy. So it's 23212958. And the second one, what is the send time? Then we need to figure out what is the acknowledgement as well. And the send time is 041737. Okay, then we come to this step. All I want you to do is to do the calculation in here. You want to use this sequence number. Use this sequence number and plus the length 1460. Then it will be this one, 038. Then you can find it is in here, 038, this one. Now we know this is the packet we are looking for. This is the acknowledgement packet of this request of this packet, the fifth packet. And we need to write down the time here. Is that okay? Now we know the time is 0.077294. How did we know the send time, right? The send time is in here in the left-hand side. Yeah. And now we come to the calculation. How can we calculate the sample RTT and estimated RTT? Do we have any question like this in the midterm exam? Okay, so you may not be very familiar with this one. Then let's have a check, because the first column is very easy to do the calculation, as the sample RTT is the estimated RTT. So how can you get the sample RTT here? It's basically this one minus this one. The receive time, acknowledgement time, minus the send time is the sample RTT. And the same as this one, equal to the receive time minus the send time. So this is the sample RTT. But how can we do the estimated RTT in the second column? As we don't have the, because this is the first column, so the estimated RTT will be exactly the same as the sample RTT. But in the second column, in the second packet, we need to recalculate it. And I put the equation in here. You can just put this equation in your Excel. It will be 0.875 times estimate RTT and plus 0.125 times sample RTT. So it will be like this. And then you can see this is the new value. Now you get the idea of how to calculate this one. Another question, why do we need to calculate the estimated RTT? Any idea? Just a quick search on Google. So the reason why we need to calculate and recalculate the estimated RTT is we want to set a timer for every packet, right? If we want to set a timer, what will be the time, the time? We cannot set a, we cannot use a fixed value for this. Otherwise, it will be too large or too small. So we need to dynamically calculate the RTT, and then we use this value as our timer in the TCP connection. So it can optimize the transmission speed and, of course, reduce the packet loss rate. This is the reason why we need to do this kind of calculation. But when you do the TCP connection, it will like do this kind of calculation automatically. So you don't need to worry about this. But in here, we want you to know what is the reason why we need to do this, because we want you to understand how this works. And then you can do the calculation by yourself after this. So this is the first packet. This is the second packet. And what is the third packet in here? Is it this one or this one? Is it 6 or 7? And the way you can identify which packet is the next packet is by looking at the source IP address and destination IP address. You can see the first packet IP address end by 102, and the second one also end by 102. So the third one will also end by 102. This is the third packet. Then you can put the sequence number 2, 3, something like this. And you do the length as well. You can check in here 1460 in here. Oh, it's 1500. And yes, it's 150. Its total length is 1500. But we only care about the TCP segment instead of the IP segment, because the IP segment, the length is 1500 because the IP header is 20 bytes and the TCP header is also 20 bytes. So it's 1460 plus 20 and plus 20 is 1500. And here is 1460. And what is the send time? It's also at the left hand side, 0.0546. And the receive time, you use this method. You use this method to find the acknowledgement of the packet, and this is the acknowledgement time. Okay. And the sample RTD will be exactly the same as we do the calculation, will be equal to the receive time minus the send time. Minus send time. And the estimate RTD will use this equation. Okay, so this is the method. How can we draw this table? This is the question 3 and 4. It's not pretty easy to do the calculation, but after you understand it, it will not be very hard. We come to here. So I put a table in here. You can just simply copy the table and do your research. Now we come to the next one. What is the minimum amount of the buffer space? In the for the buffer space, you can have a check of the SYNAC packet. It will mention as the window in here. You can see window 5840. then you can figure this out. This is the maximum value of this, and you can compare it with other packets. This one is pretty easy. And we go to the next one, and the retransmitted segment. As you can see, for the retransmitted segment, usually you will have the same acknowledgement number. If we didn't, sorry, it should be the sequence number because it's retransmit. So if a packet is timeout, then we need to send the same packet again. All you need to do is check if they are the same for the sequence number. You can see these two have the same sequence number, but are they the same content? No, they are not. And these two, no, I didn't see any. These four packets have the same segment number, but are they the same? No, they are not the same. You can check it by this way. You can also have a check of the acknowledgement number. If you have the same acknowledgement number, are they replying for the same stuff? You can have a check of the payload here. So the first one is have this content, and the second one have totally different content. That's how we check if they have retransmission. And we come to here. Question 6. Oh, that should be a easier way to do this. You can also use the statistics or analyze statistic in the TCP. Give me a sec. Let me think. Where can we find it? Oh, it's in here. The TCP string graphs. You can use this one to have a check. You just click the Stevens. Then you will have a graph like this. You switch the direction. And you can see the sequence number is increasing step by step, which means we did not resend any packet. You can generate this graph and then put it in your report. If we have any retransmission, then the sequence number will drop. Okay, so that's for the question 6. And the question 7, how much data? Okay. In this one, we need to have a check of the 60, 52 to 60, 53 to 60, 62. You can see here, in this part, we send 1, 2, 3, 4, 5. We send 5 different packets, and we get 1, 2, 3, 4 acknowledgements. This is the ACK, and this is the packet. Or you can call it data. You can see there are 6 different packets, and we have only received 4 different acknowledgements. And this one, the sequence number is ACK by this packet, And the second one is acknowledgement by this packet. Third one is acknowledgement by this packet. Fourth one is acknowledgement by this packet. I think we have mentioned this one in the uh, lecture, right? In the lecture, we have mentioned this kind of stuff. So where are these two? Where is the acknowledgement for these two packets? Nope, it's not lost. Otherwise, we will have different acknowledgement number in this part. So if we think these two packets lost, then the acknowledgement number for these three could be different, right? These two acknowledgement number is omitted. Do you know what is the reason? Because we want to save the traffic. We don't want to send a lot of acknowledgement at a time. Instead, if we have, let's say, if we have a lot of packets arriving together and we sort this out, then we can, let me clear the drawing and draw it again. So this one is this one, right? And this one is actually comes to here. This one is also come to here. And this one come to here. You can see there are three different packets act by only one acknowledgement number. In here, we receive three packets in a row in the server side. Then we just merge the acknowledgement, three different acknowledgement packets into one. And then we say, oh, we have already received you three packets. Please send me the next one. And you can have a check of this one. And you can also verify this by checking if they have resent, if the client resend this packet or not. If the client side did not resend these two packets, which means the server side have already acknowledged this sequence number, then we don't need to resend. Okay, so that's the stuff we have learned in the lecture. You can have a double check of the content in the lecture. Yeah, I think it mentioned in here, right? Lecture notes section 3.5. Basically just merge different acknowledgement into one, so we can save some traffic. And next one is the throughput. This one is also pretty tricky. I have already put the calculation in the GitHub link. Is it too easy to do the calculation if you give you the hint? Maybe I should delete this one. I don't want to specify the packet number here. But in order to calculate the throughput, what should we do? We need to have an equation here, right? It is the sequence number, because the sequence number will represent the bytes in the transmission and the time, right? So the size of the content we have transmitted divided by the time we have used. then it will be the throughput. Put it here. But why should we use this packet instead of the last one? In here, you should be aware of that we only care about the TCP packet. So please ignore the HTTP. We only care about the TCP one. But why should we use the number 202 instead of number 206 and 213? You need to have a check of the IP address in here, right? So if you're aware of the IP address and the protocol, then you will know why should we use this one instead of the last one. And why should we use the fourth one as the first one instead of this one? Yes, I want to explore this and explain in the report. It will be very helpful for you to understand. But let's see how to do the calculation here. We just select this one and scroll down to the 202, this one. How do we do the calculation? It's pretty easy. Just do the calculation here. Sequence number. What is the sequence number here? Is 2322933103. That's the value, and we need to minus 1 as well. So this is the value. Please figure out why should we minus 1 here. This is very important. And you can find the hints by checking what is the size of syn and synac, and explain why should we minus 1 in the report. Minus 1 is very important. And 164098 and divide by the time. So what is the time? It is 5.45583 minus this one, 26477. This is the time. And that's how we calculate the throughput. You just use the difference between the sequence number and the acknowledgement number and divide by the time. Then you will get the throughput. Okay, so that's the exercise 1. A lot of calculation, so you will spend a lot of time on the question 3, 4, and 8. And please let me know if you have any questions. And now we come to the exercise 2. Comparing to the exercise 1, the exercise 2 is very, very easy. All you need to do, just have a check of this table. What is the sequence number? So you just check what is the sequence number here. Basically, just in the table. And what is the sequence number sent by the in reply to the same? What is this sequence number? Is it this one or this one? Then we need to check. It is sent by the server to the client. Which one is server? The server is in here. we want the client in here, right? And we want the server in here. So this one is the packet we are looking for, and the acknowledgement number is in here. And this one is very, very easy. So I want you to do the question 3, 4, 5 by yourself. But please let me know if you have any confusion. Basically, you just use the knowledge we have learned in the exercise 1. Then you will be able to do the exercise 2. And the exercise 3, this one is not marked. So you do not put this one in your report. But it's pretty helpful for now to understand how to use the network simulator, because we are going to do some exercise in next, I think in next lab, or I think we will have 2 labs about the network simulator. We will ask you to write a program for the network simulator. You can have a check of this one. Let me show you how to play with the network simulator right now. So open the WeLab and open the terminal. Firstly, we need to download some scripts so we can play with it. But can we just, yeah, you can also enter the network simulator command in here, but don't worry about it. All you need to do is just download the script. Web browser. Download. You can't open it directly. You can open this one in the terminal and use NS simple simulator. Use this command. Yeah, so we use this command to run the simulator. So this is the command 3331 network simulator, and with the street name. This is the network simulator. As you can see here, we have 2 nodes, the node 1, node 2, and let's try to run it. Use the play button. You can see there are some transmission between 0 and 1. Is it from 1 to 0 or 0 to 1? It make me a little bit confused. Let me have a check. We can open the script and you can have a check like what is the stuff inside. It's not very hard to understand it after you know the syntax. In here we can see we create 2 different nodes, and that's the reason why we have 0 and 1 here. Node 0 and node 1. And we create a link between node 0 and node 1, right? And the bandwidth is 1 megabyte. And this is the delay. and they are using the UDP connection. And here are the flows. Start at 0.5 seconds. With the CBR, this is the packet size and interval. Okay. Okay, so it's pretty clear. With this one, at the time 5.0, no, 0.5, sorry. 0.5, it will start to send the packet. And it will end after 1 second. This is 0.5. And we will end around here. Well, 1 second. It should be in here. Yes. So this is the network simulator. That's how we run it and how to understand how it works. And in the future labs, we are going to write some script like this. And now you can play with this kind of script by using this command 3331 ns simple sin .tcl. Is that okay? I remember we also have some slides for this. Not in here. Okay, you have web page. So if you have time for this week, please go through the content in here. It will help you to understand how can we write the script. And in the next week and 2 weeks later, we will play around with the network simulator. But don't worry too much. I will teach you like from zero. For the programming stuff, we will go through the programming part together. So don't worry about this part. But if you have time, just go through all the content, make you easier to understand all the stuff. And that's it for the exercise 1, 2, 3. Please let me know if you have any questions. Beside the labs 4, we also have an assignment demonstration in here. The schedule, oh, sorry, I did not update the schedule here. It's in here. Yes, so you can check. We already have one consultation at week 5. You can have a check of the recording. Does anyone start the assignment yet? Nope. Okay, that's great. If you haven't started yet, maybe you can have a quick look of this recording. We have a quick look. We had a quick look of the specification. So maybe you can play with like 2 times speed. Like this. You can have a quick look of the content in here. You have some general idea of the assignment. Could be helpful. And in this week, we will also have a help session in Tuesday and Friday. So in Tuesday, we are going to have some tutorial stuff, like I will go through the content and do some coding job with you. Here you can see we are doing the assignment 101, how to get started with a template code and the multi-threading stuff. So if you haven't started yet, maybe you can go through the first recording and have a general idea of how this assignment is. Then you can come to the consultation in Tuesday and Friday. So for Friday, it's basically the question and answer. You can bring your question into the tutorial, into the labs in this link. Then you can ask me any kind of question of that, and I will help you to figure this out. And in Tuesday, we are going to do some demonstration of how to do the program. So it will be very helpful for you to do the assignment. If you have time, just come to the link. It will be the same link as this tutorial, as this lab. And for every week, we will have 2 sessions. And if you are doing the assignment with other languages, like the C, Java, you can also join the corresponding link. And we will also have the recording for the help session. And yeah, that's all I want to mention. You can have a check of the GitHub link in here. Let me send it to you. I send the link to the chat so you can check the schedule and the plan for the assignment demo. Yes, and we still have like 15 minutes. Feel free to leave if you have no questions. And yeah, if you have any question, you can also ask me. I will stay until the end. Okay, let me stop this recording right now.